Let's begin. Today is October 22nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 7, 9, 18, 19, 21, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our last digit, the circle digit, and the Turing machine will let us know if it's an even digit or an odd digit. Criteria card B takes a look at our 3-digit solution, and the Turing machine will let us know how many 3s are there in our solution. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing machine will let us know if if the sum is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Next, criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 general cases. One where the code has a pair, as in the example 131, or alternatively, it has no pairs, but there are 2 scenarios. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again takes a look at our 3-digit solution, the digits from triangle to square to circle, and will let us know a little bit about the ordering of those digits. Do they appear in an ascending order, meaning they're increasing, as in the example 135, or do the digits appear in a descending order, or are they decreasing, as in the example 421, or alternatively, the 3-digit code may have no order. So let's take a look at the example 231. Notice that it goes from 2 to 3, it increases, and then it goes from 3 to 1, then decreases. So that shift is one way to define a 3-digit code having no order. We've also seen other puzzles previously where if you have consecutive equal digits, and that's also a case where the 3-digit code exhibits having no order, like for example 331. When you go to 3 to 3, there is neither an increase nor a decrease. So that also is an example of a 3-digit code having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card A. I want to know a little bit about that circle digit. Okay, so the Turing machine does not approve of my choice for circle. Notice I did pick an even 4, but the Turing machine does not agree with the fact that it should be even. So it's basically informing us that actually circle should be an odd digit. So let's go ahead and type up in our notes in section A that circle is an odd digit. And of course, since it is odd, I can go ahead and cross out both evens. Okay. I think the next thing I'd like to test is criteria card C. Okay, so again, the Turing machine does not approve of my choice for a proposal. Again, we are adding all the digits up per criteria card C. So let's go ahead and do that with my proposal. So 3 plus 1 is 4. 4 plus 4 is 8. That 8 is an even quantity, but the Turing machine does not approve of that. So again, it's letting us know that the sum total should actually be an odd quantity. So let's go ahead and type that up in our notes. And that's again in section C. And we'll say that triangle plus square plus circle should be an odd quantity. And so what can we say? Well, we already know that circle is odd. So if we want the sum total to remain odd, there are actually a couple of scenarios. One where triangle and square, both triangle and square have to be of the same type. What I mean by that is either they both have to be even or both odd. And that's because whenever you add the same type of digit, both even or both odd, in both those cases, when you add them together, you get an even quantity. And of course, when you add an even to, this circle that we know is odd, an even plus odd always gives you an odd quantity. So we are anticipating a solution that's even, odd, or actually all odd. But at this point, we still don't know. Now, what's interesting is criteria card E. Perhaps, if triangle and square were both even, we could have a pair, and that would, that could be a possibility. But if it's an all odd solution, we don't know if it would be paired up or not. But still, I think it's a worthy test. So let's go ahead and test criteria card E. Okay, so the Turing machine approves of my choice for proposal. Notice that 314 has all distinct digits. So that actually falls under the no pairs scenario. And of course, the Turing machine agrees with that. So let's go ahead and type that up in our notes. And we'll say that the solution has no pairs. Okay? So obviously that means that they're all distinct. They're all unique digits. Okay? Well, that does it for this round. We did complete our 3 Turing tests for the round. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So again, notice that we did not test criteria card B, identifying the number of 3's in our solution. We also did not test criteria card D, the sum of the first 2 digits, and comparing that sum to 6. Nor did we test the ordering of the digits. So let's see. Well, since we know they are all distinct, again, based on previous puzzles, it could be that the first 2 digits add up to 6. However, there are multiple ways of accomplishing that. You could have 1 and 5 in some order, or even 2 and 4 in some order. And so I think that would be rather difficult to pinpoint as to, which is it? Is it the 2 evens that add up to 6 or the 2 odds? So I don't think the sum could be 6, because I think that would lead to too many ambiguous solutions. I just don't see it. Let's see. What about criteria card B, the number of 3's? It would be interesting if we test criteria card B, and if there are no 3's, remember, you have all distinct digits. If there is not a single 3 in the solution, then I don't think it could be an all odd solution, because if you have no 3, remember, you can't pair up the 1's or the 5's. And so if you can't pair up a 1 and a 5, then you can't have an all odd solution, which would mean that perhaps you do have 2 evens in square and circle, and then that would lead us to accept the 2-4 possibility of the sum of 6. So that could be interesting. And of course, then that would mean that circle would be 1 or 5, and perhaps criteria card C, the ordering would help us, pinpoint what circle might be. So it could be something like 2-4-1 if there's no order, or 4-2-5. But I also don't see, even though we do have this ordering, there's really nothing to say, or triangle has to be this digit, or square has to be that digit. There's no way to really pick between 2-4 and 4-2, because, you could end up with no order either way. 4-2-3 and 2-4-3 would be ambiguous. So there's really no way to pick that sum to be 6. So let's see. What else can we figure out? Well, the other thing also, we haven't really talked about whether it could be the same digit repeated 3 times. Is there anything? So I don't think it can be that, because if it were a single digit repeated 3 times, then we know automatically that there'd be no order. Similar to how I described, if you have 2 consecutive digits, equal digits, there'd be no order. Well, the same is for all 3, right? It doesn't change. So I think we can say for certain that they should all be distinct. Can't be a single digit repeated 3 times. So circling back, so I don't think, so I don't think there could be 3 3s, there can't be 2 3s. So either the 3 is there or not. And now I am sort of leaning towards maybe there is a single 3 and it'd be an all odd solution. So, and I don't think it would be like 1-5 or 5-1, the sum being 6. So I'm anticipating that 3 is somewhere in triangle and circle, but again, how would you choose which one? Besides circle, how would you pinpoint what triangle and square might be? Again, we do have this ordering. How do you pinpoint what they are? I don't. 4-2-3-2-4-3. I don't see. If there is no 3, I don't see. There has to be a single 3 somewhere. And so, I'm thinking it's going to be an all odd solution. But where does that 3 go? Well, they are distinct. So maybe the sum is either going to be less than. But again, how do you pick it? I guess perhaps if there is no order and the sum is, say, less than 6, then it would have to be 3-1, forcing circle to be 5. Or it could be that the sum, again, has no order and the sum is greater than then again, triangle would have to be 3. So I think I'm going to go with 351, and I am anticipating there being a single 3, and perhaps because of no order, it forces triangle to be 3. So let's try that out. 351. Okay, so again, one of the reasons I did choose that proposal is I'm anticipating that the sum might be greater than 6, but it could be less than. But more importantly, that there is a 3. But first, let's go ahead and test criteria card D and see what we get. Okay, yeah, so the sum is greater. So let's go ahead and type that up, and that was in section D, and we'll say that triangle plus square needs to be greater than 6. And we say that obviously since my choice for triangle and square, they add up to 8. The Turing Machine approves of it. So yeah, 8 is obviously greater than 6. So therefore, yeah, the first 2 digits must add up to be greater than 6. And so what can we say about that? Well, I think we can say that neither triangle nor square can be a 1, because if you pick one for either triangle or square, even if you add the biggest of numbers, which is a 5, 1 plus 5 is 6, and it's still too small. So that means neither triangle nor square can be in our solution, because of that fact that we need the first 2 digits to add up to be greater than 6. That said, I think everything else is still good. You could have a 2 or a 5. Well, let's see. Actually, that does bring up a good point. What if you had a 2? Well, the only thing you could add to it would be a 4, since they have to be distinct. Remember, we're looking for either 2 evens or 2 odds in triangle and square. And because they are distinct, you can't pick evens. Wow. Okay, so that's very interesting. So yeah, it can't be either a 2 or a 4. Because if you have to pick between 2 distinct evens, there's no way you could ever total up to something greater than 6. So yes, it is an all odd solution. And again, so at this point, that means that, yeah, there's got to be some combination between 3 and 5 in triangle and square. And because they are all distinct, well, that means that circle has to be a 1. So it can't be a 3 or a 5. Wow. Incredible how all these digits can be canceled. Okay, so let's see. Well, this is interesting. So we know the sum. So yeah, so we have to have a 3. I think we can deduce that there must be a single 3 because of uniqueness. So that's what I'm going to type up in criteria card B. We will say that we're going to deduce, and we'll say that the solution has a single 3-digit, and I think, let's see, based on the ordering, what can we say? I guess we can have a, I I guess technically it could be descending 531. That's possible. Or it's going to be no order, and that's 351. Let's see. Yeah, so I think it's safe to deduce B that there needs to be a single 3-digit. But let's go ahead and test criteria card F, because I don't see a way where we can deduce the ordering. Yeah, so let's go ahead and test criteria card F. Okay, yeah, and in my proposal, I obviously show no order because it goes from 3 to 5. It increases, but then it decreases from 5 to 1, and the Turing Machine confirms that. So let's write in our notes here that the solution has no order. And so I think, yeah, the only way that could happen is 351. So let's go ahead. I guess I am experiencing a little bit of lag time because my notes in F have not appeared yet. There we go. And so, yeah, let's go ahead and cross out the 5 for triangle, and then the 3 for square. And so it does seem that the solution should be 351. So let's go ahead and type that up. And so let's quickly review the potential for the solution to be 351. So again, a little lag time for the solution to pop up. All right, so 351, yes, circle is odd with 1. We've deduced that there is a 3, and it is the first digit that for triangle. The sum of the 3 is odd. 3 and 5 do add up to 8, which is greater than 6. The solution has no pairs, it doesn't, and there's no order. Well, that looks like a reasonable solution, but let's go verify. 351. Okay, so 351. Okay, yeah. So it's definitely 351. And how do we do versus a Turing machine? Well, I think, yeah, we did do only 5 tests out of 6 criteria cards. So that's always a great indication that we beat the Turing machine. But let's go type it up. So in the first round we did ACE, and we missed the first 2. And in the second round we skipped B, we deduced B correctly, and we got D and F correct. So let's go ahead and type that up. ACE in the first round. So A and C were both incorrect. E was correct. In the second round, we just tested C and F, both correct. And of course, we deduced B. So how do we do? Yeah, so we beat the Turing machine by 1 question. Well, again, looking back, I think when we first came up with the proposal of 351, and I believe, yeah, we tested the fact that there should be a single 3. I'm trying to remember. Oh, actually, no, the first thing I think we tested was, we deduced B. We tested D and we got it correct. And that just really eliminated so many digits that we were able to deduce that there had to be a 3. So that was very fortunate. And I think that's what really gave us the edge. Well, how did you do? What criteria cards did you pick, and in what order? And did you discover anything interesting that you'd like to share? Put those in the comments. If you liked the video, please give it a thumbs up. And of course, don't forget to hit subscribe so that you don't miss any future videos. Well, until next time, have a great one.